do. So what's the idea? What's the problem? What's the question? What does it think? What is it you want to do? Second, does it exist? Or is there something similar? Because then you can copy and paste. Third, build the circuit. Fourth, compile, write the program. 5, debug and test. And 6, run. Okay? So, what do you want to do? Does it exist? Build a circuit, write the program, debug and test, and run. I will write that down again at the end. What is it? It means, if we take when we're going to learn, we're going to go through the basics. So for example, in this case, it's about having an LED that blinks. On, off, on, off, on, off, on, off. Okay? That's what you want to do. What's the second step? Where do we check? On the Arduino website first, and if you don't find it on the Arduino website, just a second. Who's shouting? If it exists, be lazy, copy and paste. So luckily us, we know that Blink exists, so we can copy and paste. So we go on the website, we see what we need in terms of electronics. We then see what kind of circuit we need to build. So that's step number 3. We need to build a circuit. That means taking the Arduino, taking the LED and physically putting them together. That's what we need to learn as well. So once you put the circuit together, we write the program. Lucky us because it exists.
Sorry, can I just take some very, very quick measurements of the room?
Well, I'm in the lecture.
Oh, okay, no problem, we'll come back.
When we need, and on top of it, I'm recording it. So when we are, we need to copy and paste the program. Why? Because that's the third rule. We have to be lazy. So we can write the program, or we can just copy and paste it from here. Which one is the laziest? Thank you. So we copy and paste this program, which is from here to here, and then we check. We have an option on the Arduino IDE to check the program, and then what's the 6th step?
Right.
We run it, and in an ideal scenario, you should see the LED blinking. Okay? That's basically what it's all about. Now, I wanna build. Let's say I want to build something more sophisticated than just a blinking LED. I want to build a blinking. I want to build something. When that door opens, the LED starts blinking. Okay? So that means what? That means I'm going to have to put a sensor on that door, and when the sensor senses that the door is at a certain angle and not at another, the LED starts blinking. Simple solution. I could put a little button here. When the door is closed, it presses on the button, and when the door is open, it doesn't press on the button. That means if the button is pressed, the door is closed, LED is off, and if the button is not pressed, the door is open, LED is on. Okay? So what have I said here, which is in terms of electronics? I said button, and I said LED. Here we have the blinking thing, and what I need to find is something like a switch or a button, and let's see if there is any of that. So if I go into the tutorial, built-in examples, there might be something. I don't know, I'll have a look. So I have blink, I have digital, here I have button. And here's a circuit where I have a button. So again, because one of the reasons to be lazy, I can use this and the one with the LED, and I have to find a way of combining them to program the LED to blink when the door is open. And essentially, that's what it's all about. It's about you formulating your problem, finding out what resources are already existing, already available, either on the Arduino website or online, then building your circuit, then writing your program, which most of it will be copy and paste, then debugging and testing, and then running. All right? It looks simple, but to get you to actually do this, it's going to take the whole semester. Because 2/3 of you are not going to think about the problem, going to directly look at things without thinking about what you want to do. Then the other third, they're going to think they're smarter than they should be, so they're not going to look at if it exists, they're going to try to do it themselves, thinking it's easy and they can do it. Third, all of you are going to make mistakes in building the circuit, so it's not going to work. You're going to freak out, you're going to get stressed, you're going to tell me that I'm not teaching well. Fourth, you're not going to copy the program the way it should be copied, and it's not going to work. Fifth, you're going to forget to connect your USB cable, and the whole thing is not going to work. And sixth, by the time you reach the run program, you're going to be fed up, you don't want to be interested. You're going to lose interest in the whole thing. That's the challenge. Why? Because you need to change your mindset to the mindset of an engineer and to be very methodical in your approach. Okay? That's, in a very cocooned way, what you're going to do. What we're going to start doing from, not today because my voice is getting worse. I'm going to stop now, but what I'm going to do with you is to upload the ID onto your computer and show you that you can find exactly the same thing on your computer. But what you're going to start doing, hopefully when I get better, is you have the examples, you have the problems, you have all these, and we need to get around and try and do things. For what? For two things. First, for you to follow this approach when you design any physical computing system that you're going to use in your projects. Second, you're relying on this for basic rules that are going to help you go much further than you think you can. And these two combined are going to give you a competitive edge when you're going to reach the job market. Because you're going to be interaction designers that are capable of implementing physical computing system, capable of implementing electronic circuitry, capable of programming, capable of adding smartness, sensors, actuators into your product. And that, not only doing the product, interactive product, should it be a website, should it be an installation, should it be a phone app, but also having a physical element attached to it and also having electronics and circuitry attached to that is something that you can't find with computer scientists because they're weak on the design side, graphic designers because they don't do any products, industrial designers because they don't do the interaction. So that's where you become gold nuggets when you reach the job market. That's where you end up with the 40K starting salary. Any questions so far?
Would you be able to use the same Arduino board on multiple computers?
I don't understand the question.
Well, I mean,
That's the circuit.
yes. No, I mean, like, if you install, like, you know, if we bring in like multiple laptops, would we be able to plug it into?
Let me explain it differently. At any one time, you need one laptop, one USB cable, one Arduino, and some electronic circuit. You can change this and put something else. You can change this board and put another board. You can change your laptop and bring another laptop. Doesn't matter. But at any one time, this is what you need.
Okay.
So the Arduino board is a programmable board. That means any laptop where you have the Arduino IDE, you can use to program that. Can be a PC or a Mac. Any other question? Yeah?
What's like the final product going to be? What are we working towards to like deliver for the?
Well, that's something which is open to discussion, but in general, you could either do like a simple electronic keyboard or a little robot or something like that. So you're going to end up with something hip. I want you to end up with something you're proud of and challenging enough to get you to a high level. But we'll discuss it after a few sessions and we'll decide which level or what kind of sophistication you want to achieve. Yeah?
So basically this module is like helping us universally.
Sorry?
This module is helping us universally.
Why?
Because you said about like how this module helps compete with other courses.
But what is it to do with the university? I don't understand.
No, I mean
Universally, not university. Universally.
Like it help us as a whole, like in the job market and that sort of thing.
You, yeah. Yeah. Somehow, just by chance, turns out that I'm the one teaching you the basics of the principles of interaction design, and I'm the one teaching you the principle of physical computing. And these two are the key skills that are going to give you an edge when you reach the job market. But these are the basis. Next year you do more, and the third year you do even more. Yeah, any other question? Great, let me turn off that. Thank you, that was the first session. How do I turn